Welcome to solving systems of linear equations with substitution. I have 4 examples for you and we will be solving each one of them using this method. Substitution is a good method to apply to systems where one of the equations has one of the variables, either x or y, by itself. As you can see in this system, the second equation has y by itself. What it allows us to do is to take whatever y is said to be equal to, and that's 2x, take that 2x and substitute y with that 2x in the other equation. So I will be rewriting my first equation. I will not be using the second equation anymore. And in place of this y, because it tells me y equals 2x, I will be writing 2x. So here's your new version of the first equation. X plus 2x equals 3. It used to be x plus y equals 3, but we have x plus 2x equals 3. I will solve this equation now. Combine these two like terms, 1x and 2x. These two, that's 3x equals 3. Divide both sides by 3 to get x equals 1. So that's half of our solution. Now we have to find y, because I know the x, I need the y. To find y, you will use the fact that x is equal to 1, and you will go back into the second equation now and substitute x with 1. Now, as the reminder, the second equation was y equals 2x. I'm going to write it right here under the box. And now that I know that x is 1, I will replace that x in the blue equation with 1. So y equals 2 times 1, which is 2. So y equals 2, and that's the second half of your answer. A lot of the questions will ask you to write this answer as a point. So to write it as a point, you write your x first, 1, comma, your y second, that's 2. And it's also a good idea to check this work. I will show you how to check in this first example. I will not, for the sake of time, do it in the last 3 examples, but it's a good idea to check. So let's go ahead and check this work. I will use the first equation first. My first equation was x plus y equals 3. X plus y equals to 3. Now I know my x is 1, I just found it, and I know my y is 2, I just found that. So I will be replacing x and y with those two numbers in the first equation. So x is 1 plus y, that's 2, equals 3. This is true, so the first equation checks. We have to do the same with the second equation. The second equation was y equals 2x. Let's replace y with 2 and x with 1. So 2 equals 2 times 1. That is also true. So that also checks, which means your answer is in fact 1, 2. Here is the next example. We will be solving using substitution because the second equation has x that is by itself right here. And the second equation tells us that x is equal to 5y minus 14. I will be using this blue circle and I will be replacing x in the first equation with 5y minus 14. So here's the new version of the first equation. Negative 6, 5y minus 14, because that used to be negative 6x, but x becomes 5y minus 14. The rest of the equation stays the same. Let's solve this. I will start by distributing the negative 6. Now we'll go ahead and combine the two like terms that are on the same side. Negative 30 with the y and negative 3 with the y. That's negative 33 with the y. Now we'll be removing addition of 84 by subtracting it. And finally, I will divide both sides by negative 33 to remove that number from the y. You got your y to be equal to positive 3. Remember, that's only half of your answer because now we have to find x. To find x, I will use the fact that y is 3 and replace y in the second equation with that 3. So x equals 5 times 3 minus 14, or 15 minus 14, which is 1. So x is 1. If you were asked to write this answer as a point, you will write your x first and your y second. Please keep in mind that you should check this work, but I will move on to the next example. So I wanted to show this example to you because we do not have an equation in this system where x or y was by itself. We do not see x equals something or y equals something. Do not let this discourage you. In either one of these equations, you actually have a variable, specifically x in the first equation and y in the second equation, that is fairly simple to get by itself. For example, if I wanted x to be by itself in the first equation, I would simply take negative 3y and add it here and make it positive. On the other hand, you could work with the second equation and make that to have y by itself. So just take negative 5x and add it here. And that creates your y to be by itself. Either way you go is going to give you the exact same answer. I am going to go ahead and get x by itself from the first equation. Out of the first equation, x is equal to negative 4 plus 3y. And now we can use the fact that x is equal to negative 4 plus 3y and replace x with that blue circle in the other equation, in the second equation. So here's your second equation. Negative 5 times negative 4 plus 3y plus y equals to 6. Distribute the negative 5. That's a 20 minus 15y plus y equals 6. Combine like terms that are together here. Negative 15y and 1y is negative 14y. So 20 and negative 14y equals to 6. Now I will go ahead and take the 20 and move it to the right side. Since 20 was positive on the left, I will make it negative on the right. Negative 14y is the only thing that's left on the left side, and the negative 14 is obtained by combining these two numbers. So we divide both sides by negative 14, y ends up being a 1. Now I will use this y, that is 1, and I will put it back into the other equation. So I will go ahead and put the 1 into the first equation. So my first equation was x minus 3y equals negative 4. You could use that one and you could replace y with 1 in that equation, or you could use this version of it and replace y with 1 in that version, which to me seems easier, but it's up to you. So I will be replacing this y here with 1. X equals negative 4 plus 3 times 1, which is negative 4 plus 3, which is negative 1. So x is negative 1. Again, if you were ever asked to write it as a point, you would say negative 1, comma, positive 1. Do not forget to check, but I'm moving on to my fourth and final example. Here's the system. In the first equation, x is by itself, so I'll go ahead and take negative 2y minus 6 and substitute x with that in the second equation. Here's the new version of the second equation. 4 times negative 2y minus 6, the rest stays the same, plus 8y equals to negative 24. Distribute the 4. Combine like terms. Negative 8y and positive 8y will cancel each other out. That's a 0. So you ended up with negative 24 equals to negative 24. Some of you might recall from the video where I explained how to solve linear equations, not systems, just single equations. And we had cases where the variables were gone, which that's the case here, our y's canceled, and the final version of the equation was true, which again is the case here because negative 24 is in fact equal to negative 24. Again, if the variables cancel and the final equation is true, then the solution to a simple linear equation would be all real numbers. To a system, we will say infinitely many solutions. If so happened that your y's or your x's canceled, but the final equation was false, something like 0 equals 5 or negative 24 equals 16, anything that's not true, in that case you would say no solution.